Imagine you're facing a roadblock in your PLC setup journey. You've got an Omron CJ1M, a CS1WCN118 cable, and CX programmer installed on Windows 10. Your goal: establish a connection. But here's the catch: the PLC is second-hand, and you're in the dark about its connection parameters and Ethernet address. You power it up, and while the power LED glows green, a red ERR/ALM LED catches your eye. You've tried connecting via CS1W and direct serial, but the software keeps returning unable to connect to PLC. This is more than a hiccup, it's a critical challenge that needs dissecting. Let's dive into the nuances of this problem and uncover the exact steps and settings required for a successful connection. Now, let's dive into the fundamental principles of PLC communication. Picture this: your PLC is like a central command center, communicating with various devices and systems. The key to successful communication lies in understanding the ports and settings. For instance, the peripheral port on an Omron PLC requires specific dip switch configurations. Setting dip switch 4 to off and dip switch 5 to on ensures the peripheral port uses default settings, crucial for initial connections. Remember, the baud rate, parity, and other parameters must align between your PLC and the programming software to establish a stable connection. Misalignment here is a common pitfall, leading to communication failures. So, listen carefully as we unravel these critical components and settings, ensuring your PLC connections are seamless and efficient. Let's delve into the initial steps for configuring your PLC connection. First, ensure that the dip switches are correctly set. For the peripheral port, set dip switch 4 to off and dip switch 5 to on. This configures the port for default settings. Next, connect your cable to the peripheral port and initiate a scan. If the PLC is not detected, navigate to Tools and select Network Configuration Tool, also known as CXNet. In the window, choose Project and then examine serial ports. Here, you can specify your desired settings and verify the configuration. Remember, the baud rate, parity, and other parameters must match those set on the PLC. A common baud rate is 9600 with 7 data bits, even parity, and 2 stop bits, often abbreviated as 9607E2. If you're using a serial to USB adapter, ensure it's configured correctly, as some adapters require specific settings to function properly with PLCs. Listen carefully to these settings as they are critical for successful communication. Now, let's dive into advanced troubleshooting for PLC connections. When you're dealing with an Omron CJ1M, it's crucial to understand the role of dip switches. Set dip switch 4 to off for default peripheral port settings and dip switch 5 to on for RS-232 default settings. Use the CXNet tool under Tools, then Network Configuration tool. Navigate to Project and select Examine Serial Ports. Here, you can fine-tune settings to your exact needs. Remember, the peripheral port uses smaller connectors and is often overlooked. Misconfigurations here can lead to connection failures. Also, ensure your baud rate, parity, and other serial parameters match those set on the PLC. A common pitfall is mismatched settings between the PLC and your configuration software. Addressing these nuances will significantly enhance your connection success rate. When connecting to a PLC, especially an Omron CJ1M, you might face several common issues. First, ensure the dip switches are correctly set. For the peripheral port, set dip switch 4 to off and dip switch 5 to on. This configures the port to the default settings. Next, verify the baud rate, parity, and other communication parameters match between your PLC and your programming software. A mismatch here is a frequent cause of connection failures. Another common issue is the absence of the termination module, CJ1W-01. Without this, the internal bus can't function correctly, leading to communication issues. Lastly, pay attention to the LED statuses. A lit ERR/ALM LED indicates a hardware issue, while a blinking PRPRL or COM LED suggests a communication problem, often related to incorrect serial settings. Addressing these points will significantly increase your chances of a successful connection. To master your Omron PLC connection, remember these key takeaways. First, ensure the PLC's power and communication LEDs are correctly indicating activity. Second, verify the dip switch settings align with your connection type, serial or Ethernet. Third, double-check the baud rate, parity, and other serial parameters in your software match those set on the PLC. Fourth, if using Ethernet, confirm the IP address and subnet mask are correctly configured. Lastly, be aware of the non-standard pinout for Omron serial cables. Following these best practices will significantly increase your chances of a successful connection. And here's why that matters. A solid connection is the foundation for reliable PLC programming and operation. This leads us to our mission, providing you with the highest level of technical education for free, ensuring you have the knowledge to succeed. Subscribe for more in-depth tutorials and join our community of learners.